Hello and welcome to the Basics of Calculus. So this is the first video of the limit section of the course. So in this section what we're going to be doing is we're going to be exploring the limit really in its entirety. We're going to talk about how it applies to continuous functions, how it's going to apply to something that we'll call continuity, and how it's going to apply to what we'll call discontinuous functions. We'll also talk about limits at different places on a graph, such as going to 0, going to infinity, and the idea of asymptotes, or these kind of approaching a value that really tie in really well with limits here. So this video is going to be an introduction to the limit. We kind of already talked about this a little bit earlier on in the course. Just to recap, we talked about the idea that, we talked about the idea that math can either be discrete math or we can have continuous math. And remember, the idea of discrete math was really these distinct indivisible chunks, while continuous math, an example would be like y equals f of x equals x squared plus 2x, where we have some output as a function of some input. And discrete math, an example would be some normal operation, 1 plus 5 equals 7. So we said that the limit was kind of like the video camera of math, that the limit took us from discrete math, these pictures, these snapshots at some point, to continuous math, kind of creating a video, a continuous loop. And this is a major part of what the limit does. Let me write that down. The limit is a video camera. And this is a major part of what the limit does. It takes us from discrete to continuous math, and it allows us to create this idea of continuity. And in fact, the idea of continuity itself, as defined in math, is defined in terms of the limit. But we want to talk about, really in a more rigorous definition, what the limit is. So we'll start this off with a bit of an example. So we talked about this a little bit. Say we have a graph. We have some input x and we have some output f of x. And the graph looks something like this. So this would be an example of a limit that kind of makes a little bit of intuitive sense. So if we take a snapshot of a picture in time using our discrete math, we would say that this is where x equals 10. And then we would say that this is f of 10, and f of 10 equals, let's say, 7. So f of 10 equals 7 at this time. Write that down here. So this is great. This is kind of an example of a discrete snapshot, because what this is say that we had our function was f of x is described by, and this isn't actually what this function is. I'll give an example where it does evaluate to 7. Say it was, let's see, x minus 3 would be a good example. So say it was x minus 3, where f of 10 is equal to 7. So we can see here that when we plug in 10 for x equals 10, then we now get a discrete function. We now get, well, I shouldn't say discrete function, we get a discrete relationship. We get 10 minus 3 equals output 7. So we can see that by taking a function value at a specific point, taking f of x at one point creates a discrete relationship. And that's important to understand, because what we're doing here is we do have this idea of a continuous function, but when we take something at a specific point, it creates this idea of a discrete relationship. And this can kind of ruin how we want to talk about behaviors of functions, because we want to talk about behaviors at multiple points. Say we want f of 10, f of 11, f of 14. We want all of these points, and each of these are discrete. This is a discrete point. And taking it at the discrete point is going to give a discrete relationship, whereas we want to know the behavior across all of these. And so that's where the limit comes in. This limit says it is what the function approaches. So we'll write that, because this word approaches is very important. What the function approaches as the input approaches some value. So what does that mean? What that means here is that it's not talking about what the function value is at that point. It's not a discrete relationship. It's asking about behavior. This has to do with behavior of the function over time. And in a lot of cases, you'll see that it does end up being similar to what the function value is at that point, and that should make sense, but we're talking about behavior specifically. So we're asking what the function approaches as the input approaches some value. So if we draw our graph again, we'll draw it down here, and I'll actually draw a linear graph to represent our functional relationship. So f of x is equal to x plus 3, or sorry, x minus 3. F of x is equal to x minus 3. So it should look something like that. As you can imagine, it goes down here to the negatives. And so we'll get 10. It's right there. And we know the value is 7, but we want to know what it approaches. So how can we find that out? Well, the only way we know how to do that so far, because we haven't really been introduced to the idea of limits or any analytical techniques to solve them, the only way to do it is to take the values at discrete points. So what we can do is we can say, okay, I'll start here at 5. What's the function value at 5? Well, it's 2. So you can see f of 5 is 2. That's good. So now what we can see is we can continue this. We said we're approaching 10, so let's approach 10. Let's get to 7. What's the function value at 7? Well, the function value at 7 is going to be 4. So it's going to be 4 there. Okay, function value at 9. Function value at 9, I'll draw it in right here. Don't really have room to write it, but you can see it would go right there. Function value at 9 is equal to 6. What about function value at 9.5? Well, that's going to be equal to 9.5 minus 3. That's going to be 6.5. What about function at 9.9? That's going to be 6.9. And we could take this to be function at 9.99, so on and so forth. That's going to be 6.999, and so on and so forth. So you can see is that over time, the limit is talking about this process. What is it approaching as we get closer and closer to 10? So you can see as x gets closer to 10, what does f of x do? What number, what does f of x approach? What number does f of x approach? And you can see here that we can see that f of x approaches the number 7. So we can say f of x approaches 7. And this should make sense, right? Because if you imagine, when I go along this line, I'm approaching 10, it's like I'm traveling up the graph. And I'm traveling up kind of in the direction of this arrow, and the closer I get to 10, the closer I'm going to get up here to this point, which is going to be 7. And you can see that that's kind of how that's going to work. We're going to approach 7. And so that's what the idea of a limit is. I don't want you to get confused by thinking a limit is just the function value, because we're going to talk about later on in this section, we're going to talk about how situations where that might not be the case, or situations where you don't have a function value. But in this case, what we want is we're showing how it approaches that singular value. Okay. Hello, and thank you for watching. This video is a clip taken from an online course I've been working on called The Basics of Calculus. The course is really a way to educate people about calculus in an engaging and understandable way while still teaching useful skills that can be applied in the real world. If this sounds like something you'd be interested in, I will be posting a link to the course down in the description as soon as it gets published, and I hope that you guys can check it out. I'll also be coming out with more videos from this course to share with you guys as I get closer to finalizing it. Although the full course is only available through the link below, so if you're interested, please check it out. Finally, if you would like to watch the full version of this clip, I've posted a link to that down in the description as well. Again, thank you so much for watching, don't forget to like and subscribe, and I hope to see you next time.